What is the volume of the sphere?
It is the cone is the 1/3 of the
So in front of you now, I was explaining a part. Could you please tell me what this means?
This is the volume of the sphere.
Okay, and what about the first part? 2/3 by r squared times height. What this means? 2/3 by r squared times height. That means what?
Two-thirds is the volume of the sphere when it I don't know بصراحة يعني.
Yusuf? Yusuf?
Yes, miss.
Could you please tell us what do you have in our screen? We were talking about what?
Volume of sphere.
Yani this part, the first part at the top, did you see 2/3 by r squared times?
The volume of sphere according to the cylinder.
Thank you so much. This is the volume of the sphere according to the cylinder. Thank you. Kenzie?
Yes, miss.
What is the height of the sphere? The height of the sphere equal what?
Equal to r.
Thank you. Equal to r. For this reason, we replace 2r instead of what? Instead of height, right? And after that, we compound the numbers together, which is 2/3 and 2 together, and r squared, and then the r together. And we said that r means that we have an exponent 1. After that, we put 4, 2/3 times 2, it will be 4/3, and then we keep by the same and r to the power of 3. So this one now represent what? This formula now represent what? This formula represents volume of a sphere, right? So we started in this chapter, we started volume of cylinder, right? And second, we started what? Volume of, what was the second shape? Of cone. And today, the last part, volume of sphere, right? So we studied volume of cylinder, volume of cone, and volume of sphere. So this is, as I said, this is how we can find the volume of the sphere, which is related to the volume of cylinder. The second part, which we want to talk about it today, how we can finding the volume of a sphere in real world problems, right? So again, what we are going to talk about now. Yes,
Miss, I have a question.
Yes, honey.
The hemisphere, we get a sphere بعد كده نعمله divide to?
Yes, yes, it's half of the sphere. Okay? This is question. You're welcome, honey. Okay, so we will continue now how we can use volume of a sphere in our real life. Does anyone have any idea? How we can use a ball that's spherical. There's so many: basketball, soccer, golf, racquetball, look at them all. Well, early forms of bowling date back to ancient Egypt. They used balls made out of husks of grains that were covered in leather, then bound with string. Some were even made of porcelain. Well, today, bowling balls are made of polyurethane. It's a type of plastic. Tala uses a 13-pound bowling ball when she bowls in her league, and its diameter is 8.5 inches. So what was the volume of polyurethane needed to make her ball, not counting the finger holes? So if the diameter is 8.5 inches, that means from this point all the way over here, we just need half of that. Half of 8.5 is 4.25. the theorem. In the formula for the volume of the sphere, did we use radius or diameter? In the volume of sphere, did we use volume, did we use diameter or radius? Yes, Usama.
Radius.
We use what? We use
Radius.
radius, right? So we said that the theorem for the volume of the sphere with the radius of length is given by volume equal 4/3 by r to the power of 3. So once we have the diameter in the question, so we have to do what directly, grade 7, grade 8?
Divide by 2.
We will find the radius by dividing diameter divided by 2. So take care about this part. Once you have the diameters, then you have to divide it by 2. Let's continue. Is the volume V of a sphere with the radius of length r is given by V equals 4/3 times pi times radius cubed. And that's the formula for the volume of a sphere. Remember, the diameter divided by 2 is the radius. So if it gave us the diameter, we just need to divide that by 2. Now, we could have also used that this way in the equation. I decided to go this way and just divide it by 2 before I started. You can also write it so that the diameter is divided by 2 inside of parentheses cubed. Now, the parentheses are very important, and I've spoken about this before, but I figured it might be smart to just redo this. It's so important to have these parentheses around the little fraction d/2 and then have the exponent on the outside. Without the parentheses, that means that the diameter of 4 inches of a ball would be 4 cubed divided by 2. So that means we're going to cube the 4 and then divide it by 2, because in order of operations, we do. Did you understand this part? Did you understand this part? What is the important for the parentheses? If you don't want to divide diameter divided by 2 at the beginning, and you want to use d/2, and d, as you know, donated for the diameter, do we have to put a parentheses, or we can ignore the parentheses? Yes, Hannah.
No, we have to put a parenthesis.
Yes, we have to put the parentheses, because without the parentheses, we said that it's r to the power of 3, or d/2 all to the power of 3. So without the parentheses, we will count exponent 3 above only the numerator, right? So it will be 4 to the power of 3 divided by 2, because you ignore the parentheses. Then it will be 4 times 4 times 4 divided by 2, which means 64 divided by 2 equal 32. And this is so too far from the diameter. We said that the diameter, for example, was 4, and this example here in front of us, it was 4. So the radius, it should be equal how many? So the radius, the diameter was 4, so the diameter, the radius, it should be
2.
2, right? But 2 to the power of 3, because we said r to the power of 3. But if you will put d/2 without the parentheses, you will make it like this. So you will find that diameter to the power of the radius to the power of 3 equals 32. And this is totally wrong. For this reason, if you want to use the d directly in the question, so you have to put it inside the parentheses. So it will be 4/2 all to the power of 3, which means 4 divided by 2, it will be equal to the power of 3, it will be 2 times 2 times 2 equal 8. Okay, so please try to avoid this mistake. If you don't want to calculate the radius at the beginning and you want to use the diameter directly, then take care to put your step inside a parentheses. Understood this part? Understood this part?
Yes.
Okay, so let's continue. So we will back to the question.
Thirds times power times pi times the radius cubed. So because we're doing pi, it's going to be approximate because pi has so many digits, right? So we've got 4/3 times pi as 3.14, and then it needs to be multiplied to 4.25 because 4.25 is the radius, and we need to cube that, see? Now, as I've said before, when we're doing these volume formulas, like for the cone, you multiply 1/3 to pi, and now we're going to do 4/3 to pi. It's really smart to write in your notes that 4/3 times pi is going to come out as 4.18. It's 4/3 times the pi, like here. It comes out to 12.56/3. And when you do that division, it comes out to 4.18. If you write this.
So if you want to find the answer in a quick way without using calculator, then 4/3 times pi, you know, the value of pi was 3.1400, right? Or 1400. Then it will be directly 4.18. So if you want to use, we said 4/3 pi r to the power of 3, right? Then if you want to simplify 4/3 pi, so it will be 4.18 times r to the power of 3. This is in case if you are going to answer the question without using calculator. Then you will multiply by r. Understood this part, grade 8? Hello, grade 8?
Yes.
We will
Yes.
just simplify after that, and don't forget that at the beginning it will be 321 cubic inch, because we are talking about what? Because we are talking about what? Why cubic inch? Because we are calculating what? Volume of volume, right?
Yeah.
We said volume, it should be cubic because we are talking about 3D figures, right? Let's continue.
So to itself, it came out as 18.0625. I rounded that off to 0.06. We only need to go to the 10th anyway, but to be accurate, I decided to include the hundreds in case that affects the tenths. So I multiplied 18.06 by 4.25 and got 76.75. I'm going to round this 7 to an 8 because the 5 tells it to go up to the next number. So I've got 76.8. Now I'm going to multiply the 4.18 by the 76.8. And I did, and I got 321.024. And because that 0 is so small, I just left it at 321. So that's 321 cubic inches. 321 inches cubed of polyurethane to make Tala's bowling ball. See?
Okay. Now please open your book, page 415. Grade 8. Could you please open your book, page 415. Question number 21. Book page 415. Question number 21. Yes, Nano.
Write the steps you would use to find the formula for the volume of the figure at the right.
Yes, the figure in front of you is what? In our book page 415, question number 21. What do you have in this figure?
It's a cylinder with a hemisphere.
Yes, it's a cylinder with a hemisphere. So the figure in this one consists of two parts, right? So we have a cylinder, right? And at the top, we have a hemisphere. This one, okay? Then, what did the question say, Nano?
To list the steps to get the answer, yeah.
Yes.
To get the volume.
Yes, the steps to get the volume for this figure. So we said that this figure consists of cylinder and hemisphere, right? So could you please tell me your plan to answer this question?
The sphere first
Yes. Then you are going to find the volume of the sphere, right?
equals 4 over 3
Mm.
times pi times r to the power of 2 to the power of 3.
Okay. Did he put for us any dimensions in this question?
لا, no.
He didn't, right? He didn't put any dimensions in this question. But he put R and R and R, which means he wants to calculate the volume of this figure, right? In the question, he said, write the steps you would use to find the formula for the volume of the figure. For this reason, we are going to use only R according to the formula for each one. So now I will let you say your plan to answer this question, Yana. I'm hearing.
4 over 3
Yes.
times pi times r to the power of 3.
Exactly. This is, you are talking about the volume of
sphere. بعد كده all divide
Thank
2.
you. So the first step, Yanano, you are going to find the volume of a sphere, right? Which is, as you said, 4 over 3, and then by r to the power of 3. So this is the first step, by r to the power of 3. Okay, second step, Yanano.
The sum will be divide 2 because it's a hemisphere.
Exactly. So we are going to divide, right, by 2 because we are talking about the volume of a sphere, a volume of hemisphere. So we will say that divide by 2, right, to find the volume of hemisphere. Thank you. So if you will divide 4 over 3 divided by 2, so it will be how many? It will be 2/3 by r to the power of 3. By r to the power of 3. Okay, so we finished now the first part. The first part we found what, grade 8? Number 1. We found what? Huh?
The volume of the sphere.
Of the volume of the sphere, and then we divided the volume of the sphere by 2 to find the volume of the hemisphere. Right? Okay. Now, we will find the volume of number 3. We will find the volume of
cylinder.
Cylinder. Yes. Okay. So we are going to find the volume of cylinder. And the volume of cylinder equal what? The volume of cylinder. Yes, ya Judy?
By multiply R2 multiply height.
Yes. So it will be by R to the power of 2 multiply by height. But here we have to note something. We will note what? What do you note here? Note that the height equal how many? The height equal what? In this question, which he gave it to us, equal R only. In this question, look at the figure, which he gave it to us in the book, right? So the height equal R, which means we will substitute the value of H here in this question by R. He gave us the height of the cylinder. يعني cylinder in our book, he said that the height of the cylinder represents only 1 R in the for the height. Like this, he draw like this, okay? Then we will replace the volume of the cylinder, it will be by R to the power of 2 times R. So the volume of the cylinder in this question, it will be by R to the power of 3. By the end, he wants to find the volume of the figure, all the figure, right? Then it will be the volume of the cylinder and the volume of the hemisphere. So it will be 2/3 by R to the power of 3 plus by to the power of 3 equal 5/3 by R to the power of 3. So this is by R to the power of 3 equal 5/3 by R to the power of 3. So this is the question in your book, page 415, question number 21. So this is how we can use only the dimensions in a hemisphere and the cylinder to find the volume. So please, this is a very important question. You can watch the video again, and please, you can answer it by yourself. Before we will end, is there any question? Because we have less than a minute. Do you have any question you want to ask me about it?